Welcome to Unit 3, Lecture 3, Section 7.2, talking about causes and effects of global change. Learning objectives. Explain how human activities change the atmosphere and climate. Describe how changes in the atmosphere drive climate and other changes in global systems. Explain how human land uses can cause changes in global systems. Portray the different kinds of pollution that lead to global changes. Okay, we've seen this picture before. We've looked at this picture quite a bit. So we have the atmosphere, we have the biosphere, the hydrosphere, and the geosphere. There are things that humans do that impact every single sphere in this, or every single one of these spheres. Okay, the atmosphere, all right, even just by breathing, we are participating in the atmosphere. But then our activities, heating, air conditioning, electricity, all right, those end up resulting in changes in the atmosphere. Biosphere, hunting, okay, changing forests, okay, if we need to cut down for farmland, if we need to cut down for houses, okay, geosphere, drilling, right, drilling for natural gas, blasting out mountains for tunnels, roads, all of that kind of stuff. And then the hydrosphere, by changing the biosphere, especially by removing ground and covering it with concrete or asphalt or stone or buildings. Okay, that hydrosphere, we're actually affecting water getting back into the groundwater. So we do things at every single level just by living, which is going to happen, but then these affect all of the other spheres, because we've talked about how all four of these spheres actually interact and intersect with each other. So we are participating in every single one of these spheres on one hand just by being an organism, being a species, being a population on the planet, but then also by doing the things that we do that are different than if you were to compare us to our closest genetic living relative, the chimpanzee. Obviously, the chimpanzee is not paving roads, so there's a little bit different between, there are things we do that are similar to the chimps, but then there are things we do that are different than the chimps. We have been gathering data in climate research for a very long time. And we have seen that the carbon dioxide levels are actually increasing. And it shows that most of that is related to the Industrial Revolution. And in the Industrial Revolution, that's where we were really starting to get machines that were powered by more than just human power. So we were getting things that did work, okay, that was more than by burning coal, making heat, okay? That's the big thing, is making heat, all right? And that heat energy would push a turbine or push a machine or push something, as opposed to us just like pushing it with our hands or pushing it with our with pedals, like on a bicycle, okay? So that Industrial Revolution has changed the way carbon dioxide is released and then absorbed, okay, through the different spheres, right? Atmosphere to biosphere, atmosphere to hydrosphere, okay? And most of it is released or is caused by the burning of fossil fuels. So climate change, there's been a couple of terms that have gone on here, and they kind of get interchanged with each other and used synonymously when they're not really synonymous. Climate change is where we're actually measuring long-term changes, because we're talking about climate, okay? Because remember, what is climate? Long-term patterns. We're looking at long-term changes in temperature, clouds, winds, precipitation, and extreme weather events. So this isn't just it's getting warmer. It's way more complex than that, because it's not just that we're seeing a warming trend, we're also seeing more extreme changes. You know, we're seeing more severe storms. We're seeing more dramatic swings in temperature. The fact that in some weeks We can be at 70 degrees one day, and then 4 or 5 days later, it's 50 degrees. Okay, in a 4 or 5 day pattern, that is a dramatic change, okay, which shouldn't happen. Now, global warming, okay, this is where we're actually talking about the average increase in global temperatures. So this is a piece of climate change, okay? Global warming is a piece to climate change because we're talking, we're talking about the temperature. But climate change actually encompasses a lot more than that, okay? Climate change also encompasses dramatic snowstorms, all right, or ice storms, all right, talking about changes in hurricanes, the amount of hurricanes, the amount of tropical storms, okay? So there's more to it, but they are related, but they are not synonymous. Part of our issue is we've had changes in land use, okay, which is part of the atmosphere, part of the hydrosphere, all right, because forests, okay, and if you look 1620, okay, 500 years ago, okay, 500 years ago almost, or 400 years ago, I can do math, right? 400 years ago, most of the country were forests, okay, lots of forests. It's one of the reasons that the colonists, you know, ended up coming over here is because we had, you know, lots of trees for wood to build ships, masts. It's one of the reasons that some of the foreign powers that be were interested in this area as a colony. Okay, but forests help protect water. Okay, they help to absorb carbon dioxide, and in that process, they actually help to moderate climate. And so what that did is forests are actually really important to maintaining the four spheres. Okay, forests, trees are really important at maintaining those four spheres. And as our land use has changed, those four spheres are getting impacted at many different levels. Okay. So a loss of forests can have a negative effect on soil quality. So deforestation is just talking about the loss of forests. So if you look at this, okay, fresh water, that's the hydrosphere. Okay. Carbon dioxide, that is the atmosphere. Okay. Soil, that is the geosphere. Okay. And trees are forests, you know, so that is the biosphere. So in this small little example right here, the change in land use in the U.S. over the course of the past 400 years, okay, has dramatically affected all four spheres in this country. Monoculture, okay, is where we're actually planting the same crop, okay, year after year after year on such a large scale. That's mono means one, culture, okay, cultivating it, growing, agriculture, all of those things. And so what happens is we constantly, you know, and this was a huge, crop rotation was a huge thing for back during early American history. Was if we wanted to protect the soils and keep the crops, we had to crop rotation. But now with modern technology, between fertilizer use, water use, and so on and so forth, we don't actually have to rotate crops. But what that does is that dramatically affects the geosphere here, because we are dramatically affecting the soil nutrition and health. Development and urbanization. It's just building towns, building buildings. Okay, and as we develop, we create more and more cities and suburban areas for people to live. What that does is we create dense, huge population density, okay, and that puts us clumped, and when we're clumped, we end up producing large waste, a large amount of waste that has to be dealt with. We produce a lot of things that have to be dealt with. So there are certain things to be said about cities from a socioeconomic standpoint, but there's also things to be said about cities from a biological and ecological standpoint. Because when you start clumping populations together, okay, things for good or for bad happen. Habitat loss and fragmentation and restoration. So habitat loss is when we lose habitat, okay? When natural habitats are changed, and so therefore species change. One of the things I did when I was in college is I did research for a Christmas tree farm that no longer wanted to be a Christmas tree farm. So it was going to allow secondary succession to happen. And we went in and we were researching the mammal populations. We were researching how that succession was actually occurring. And so habitat loss is when we first originally made that into a Christmas tree farm. And what we did is we took away the natural habitat and we changed it. And so the species that once would have lived there, because it was supposed to be a temperate forest, not a Christmas tree forest, okay, once the species that had lived there, then we have habitat fragmentation. Habitat fragmentation is when we actually break the habitat up and turn it into smaller things. So if we were to take Yellowstone, which is a huge patch of land, and start chopping it up and maybe putting some houses in there and some roads and some buildings and so on and so forth. So while the entire habitat isn't necessarily lost or destroyed, we're starting to chop it up into pieces. And there's actually a whole part of ecology that actually studies them as habitat islands and island biogeography. And then habitat restoration. So this is the good things we can do to try and live and recreate habitat, restore it to what it could have been, would have been, should have been, and to a certain extent allow it to go through secondary succession to kind of return to its original state. Invasive species, we talked about those with the mussels, we talked about those with the pythons, okay? What happens is invasive species, when they're introduced to a new habitat, they become invasive and they can actually cause a lot more damage. And like I said, we've talked about this before. And then last but not least, we have biological magnification. So biological magnification is exactly what it sounds like. Biological, dealing something with life, okay, part of the biosphere. Magnification, getting bigger. A lot of times we see this with different types of pollution, especially in waterways, because what happens is we'll sample a water, we'll take a water sample and we'll set a limit on it, okay, it's this limit, whatever, okay, whatever that number is. But what happens is as that chemical goes up through the trophic levels, okay, it actually gets more and more concentrated until ultimately it's reaching the top where it could actually be in a lethal concentration. So when it's down here at the bottom in the water, it may not be that much, but as it progresses through those trophic levels and it gets eaten and taken up and absorbed and so on and so forth, it actually becomes more and more concentrated into dangerous levels. So in the food chain, the concentration of a pollutant, blank, as the number of organisms at the trophic level. So the concentration is actually increasing, and it's increasing by such a large amount that it's actually disrupting the trophic levels and actually getting more dangerous as the trophic levels go up. All right, have a great one. I'll see you in class.